Hi, everybody, and welcome to our next Conversation Aviation podcast. Today, we're going to be talking all about the topic of CPDLC. So, hopefully, you know who I am, John Franklin. I'm Head of Safety Promotion here at EASA, and I'm joined today by two great guests. And you can't talk about a topic like CPDLC without having somebody from the controller side and somebody from the pilot side in the cockpit and kind of talk about the different bits. So, yeah, we have a pilot and we have somebody from the controller side. So, maybe Viktor, can you maybe start by introducing yourself and saying a bit about what you do and that kind of thing?
Yes, hello to everyone. My name is Viktor Jagasits. I work at the Eurocontrol Maastricht Upper Area Control Center, or MUAC. We are controlling the airspace above 24,500 feet over the Netherlands, Belgium, Luxembourg, and the western part of Germany. And dare I say, we try to push the most CPDLC clearances around in Europe. I'm also involved in systems development for the past 12 years. I'm the coordinator of the systems monitoring and revision team, which is a link between the engineers and the controllers devising new system developments. And I'm also the co-chair of the Eurocontrol operational focus group, which is in particular subject with the data link usage in Europe.
Fantastic. Thanks. It's great to have you on board. And Pieter, maybe you can introduce yourself next.
Yeah, sure. Hello, everybody. I'm Pieter van der Lubbe. I've been a pilot with KLM for the last 9 years, of which the last 5 years, the most recent years, on the 737. And besides that, I'm also what we call the business pilot safety, which is kind of like the interfacing between our safety and standards compliance organization and my own 737 unit. And well, my feeling with this topic is I'm normally on the user end of the side, on the other side of Viktor, basically, the one who's getting beaten by air traffic control because I forgot to log on when I fly into upper area control. But besides that, I'm a huge fan of CPDLC. So yeah, I'm looking forward to this conversation. Yeah.
And maybe, Viktor, if I come to you first from the controller perspective, certainly we have people who maybe from safety teams in airlines or engineers and people who don't use it every day. Maybe you could start just from a controller perspective, explaining just really quickly what CPDLC basically is and what it does in the aviation system to help aircraft get safely from A to B.
Sure thing. First of all, it provides us with a way to communicate with the pilots, not only via voice, but via short messaging. These are all short, structured text messages that we send to pilots. So don't imagine a controller typing on a keyboard and sending messages. It's just like your average Windows menu where you select what you want to send and then hit the send button, and then it goes up to the pilot. There are a set of messages implemented by every air navigation service provider, depending on the needs, depending on the structure of the airspace. Think of climbs, descents, heading messages, proceed direct to contact. So the most basic messages that are use of air traffic control. Why is it good for the controllers? Because sending a CPDLC message literally takes 1 second, while saying the same message on the frequency might take 5, 8, 10 seconds, and then we still have to listen to the readback. So a complete message exchange on radio might take up to 15 or 20 seconds, while it takes 1 second from the controller side on CPDLC, and probably another 15 seconds from the pilot side on the other side. But I'll let Pieter chip in on that one.
Yeah, and then maybe on the pilot side, then Pieter, yeah.
Yeah, well, that's highly dependent upon the system you've got aboard the aircraft. And I know there's this huge part of interfacing due to, in our instance, the 737. The interfacing part we got on board the aircraft is the control display unit, or the multifunction control display unit, which is also used for navigation and performance calculations, all that sort of stuff. So once you enter the CPDLC menu, you therefore get out of the navigation part of your CDU. So you got to open messages, you got to read it, you got to respond to it, and yes, indeed, it's quite fast. And the upside is there is no complication, or there's no misunderstanding about the message which the air traffic controller is trying to get to you. So there are no double transmissions. So it's definitely a time-saving thing, absolutely. On the downside is we tend to get quite a few messages which have less value, I would say, because we are connected to a certain center. But I think Viktor knows this better than I do. And we get transferred all the time to the next sector. And once we got connected to the next center, we get another message which will say the next sector will be. So therefore, what used to be one voice message now tends to get 3 to 4 CPDLC messages. So in terms of time saving from a cockpit point of perspective, that it's not always true. Let's put it that way.
And in the cockpit, do you get like a notification? Is it easy to see? Right, we've got a new message. I need to go into the menu. How does that? Does that? I guess that
Yeah,
depends on the
well,
aircraft.
it does, yeah, and it's a feature which they added later on. So we get this pling plong every time we get this message, and part of the pling is also used for a cabin call. So every time it's a question whether air traffic control tries to reach us, whether it's a company message which has the same pling plong, or whether the purser is trying to ask us something. Yeah, but the number of tunes in the cockpit has increased significantly. Yeah. So we do get a notification. Yeah, but in a way you can see that this is a system which I think has evolved from a North Atlantic point of perspective, where you would only get a message at 30 degrees west, for instance, instead of flying in Europe, where I get up to 12, 15 messages flying only in the southern part of Germany, for instance.
And yeah, so it's in terms of the number of messages that get sent. Are there automated? There are automated messages that come as you pass through a system, and then specific messages that come from a specific controller with specific instructions. Yeah. I guess that's the way it works, I guess.
Absolutely, and the instruction messages, you definitely want to get this pling plong. It'll grab your attention. That's the one you want to focus on. But the system generated messages in terms of connection and next connection, yeah, that's not much of an interest to us.
And I guess from both sides, maybe if I start from a controller perspective, by being able to see the written message, avoid some of the kind of hear back, read back kind of challenges that we're all used to in normal voice communication. So there's kind of lots of benefits in that context, though.
Absolutely, and I know it's been a long-standing request from airlines to quantify the safety benefits, because that is a very difficult task to quantify the safety benefits. So at MUAC, we did some research actually last year, and we could spot a lot of occasions where CPDLC actually could have helped. And think of misunderstandings of a call sign. So we only record incidents as an incident as such when somebody deviated from a clearance. So let's say I'm talking to aircraft 1 and aircraft 2 takes the same call just because of similarity in the call sign or just because of mishearing. If nobody deviates from the clearance and the controller just hears that it was the wrong aircraft reading it back, they say, okay, no, not for you, correction, you maintain the level, you do this, you do that. But when somebody deviates from the clearance, then we have a record of it. So out of that, in the 2018-2022 period, we have more than 237 recorded occasions when people misheard their call sign or their clearance and then deviated. In those cases, CPDLC would have provided a very big safety advantage, because you only address the aircraft which you want to talk to, in quotation marks. Nobody else sees that message, only the aircraft who is addressed. So in those terms, first of all, with the cross transmissions as well, that you don't have 2 aircraft reading back at the same time, and also for the loss of communications, since we allowed controllers to uplink contact messages for aircraft which don't reply to radio calls anymore, we have probably saved a couple of intercepts by the member states' militaries. So it is a huge safety benefit, first of all, but yeah, it's very hard to quantify why.
Yeah, and it sounds really, at a practical level, it's like having a two-way conversation in a sense, rather than a one-to-all conversation with one controller or on a particular frequency to X number of aircraft who are all on the same frequency. So it's kind of in that sense quite easy. And I guess that works the same for you in the cockpit, is that it's an element of more focus for you. Yeah.
Definitely, and it's well, as you might know, we got a flight number, but we also got a different call sign. We got different call signs because there's so much call sign confusion possible with all different KLM aircraft going in the same direction. So yeah, this is definitely a huge advantage that you can target one aircraft instead of all the other KLM aircraft. The LOSCOM situation, unfortunately, maybe hand in own pocket. I've had it one time as well, that I was saved by CPDLC. So basically something like, well, we lost you. Please contact this frequency. Yeah, it works tremendously. Absolutely. Yeah.
And in terms of specific, you talked already about some of the challenges that you have both in the cockpit and sometimes in the control center as well. But there's two specific ones that certainly we've been focusing on in our last magazine, and maybe we talk a bit about the first one, the UM79 cleared to position, etc. via, that's one example specifically where we're trying to kind of promote what the challenge is. I don't know, maybe Viktor, you want to start a little bit on that first about what that challenge is and particularly the key things that people should remember in that context.
Sure thing. So the message, what we're mentioning is the UM79, that's the code of the message, uplink message 79, which is an airborne reclearance of an aircraft to a new waypoint by a new route. Now, this message stems from the old times, the early fans days over the ocean, where the developers in the same room were probably mostly engineers, definitely not controllers and pilots, because if there were any controllers or pilots involved, then they would have said, okay, make it very, very simple and understandable. So the problem with this message is that it starts with cleared to, and then it says the last point where the clearance belongs to, and then it lists you all the points which are before. So clear to point 6 via point 1, 2, 3, 4, 5. And on different aircraft, it's a different implementation of the display. Some aircraft show all the points on the same page, still with the same wording. But some aircraft only say you're clear to point 6 via route clearance. And that's when all the problem starts, because it's not a message that was very widely used in Europe until recently. So pilots are not very much subject to it. It's probably part of the, I don't know how many hours CPT on CPDLC. And it's one of the many that you need to learn, but it's not very much used. It wasn't very much used. And that leads to misunderstandings, because all you see is clear to. Well, you could get a very similar message, which is the proceed direct to, which is indeed a single point clearance. There you go to the point which it says on the first and only line. So pilots only need to remember that if it's a clear to, then I have to keep looking until I find at least one more point. But it is a challenge because they are dealing with other things as well at the same time. So it's not easy for them, I bet. But it unfortunately leads to some very nasty situations for both sides, because an aircraft can deviate from the clearance, meaning that they can turn into active military areas, into military aircraft or other aircraft, or into airspaces where they are not expected. And it's down to the controller to spot the deviation before an infringement of separation or an infringement of airspace happens, which is not always possible considering the highly loaded frequencies, because if something like that happens, the only way to correct that wrongly taken clearance is by going on voice, addressing the aircraft and telling them, look, that is not what I expect you to do this and that.
Yeah, and at that point we threw out the whole air part in between, all the waypoints and airways. So we start typing or we start sweating. That's basically what it comes down to. On top of that, from a voice point of perspective, the clear to instead of the direct to sounds similar like O navigation to. It's all used by different air traffic control centers to direct you to a certain waypoint. So once we read clear to, fine, click on top, and we're done. We're there, and everything in between is erased basically. So yeah, it did had some frowns in the beginning. We're getting there, to be honest. We gave some attention to it because, as Viktor said, the implication is somewhat bigger. Yeah.
Yeah, and I think that's, in terms of what we were doing in the article and the messages is really, promoting those two differences of cleared to and then see where are you going via if it's cleared to, and if it's proceed direct, then you can almost forget the rest and it makes life a little bit easier.
Exactly.
And then the other one particularly that I know there's been some focus on is UM148, when you can accept. Again, maybe Viktor, you can explain a little bit more about that challenge and what that means.
Yeah, sure. So on top of the instruction messages in CPDLC, there's also a possibility to ask pilots to report certain things. as well for the purpose of not doing that on the voice frequency. So one of these messages is the when can you accept flight level, when can you accept speed. There's a bunch of them. We have seen problems with the mentioned UM148, which is the when can you accept a flight level. This is used for different purposes, typically because when you fly around in Europe, different countries apply different flight level allocation schemes, which means that in general, when you fly westbound, you're flying on an even level, so 300, 320, 340, 360. While you fly eastbound, you fly on an odd level, so 35, 37, 390, and so on. But in some countries, because of the traffic flow being different, they don't apply the east-west, they apply the same thing north-south. So there's a typical scenario and use case for this at the Belgian-French boundary, when if you fly southbound, you have to be at an odd level, even though you're flying southwestbound, where other countries would put you on an even level. So in that case, we have to ask the aircraft, well, the pilot, can you take 1,000 feet higher, or should I make my plan by descending you because the French controllers need you at an odd level? For this case, we can use this message, when can you accept? And then we receive an answer back from the pilot, I can accept it at this and this time. That can be the now time, that can be time in the future. And then the controller can make the plan and act on it. The problem that has risen with this clearance is actually post-COVID, right after COVID, that some aircraft implementation are trying to be very human-friendly, and they fill in the answer field already. So what the pilot sees is when can you accept flight level 370, and right below the aircraft prepare the answer, now I can accept level 370. And all the pilot sees is looks down, now 370, okay, off we go. They think it's a clearance, which brings up further issues with the separation, and that is why we brought it to EASA as well, because we needed to get out to the pilot community and think about how to handle this message without misunderstandings.
And what's your experience? Have you had any experience of that, Pieter, at a pilot level?
No, because simply my aircraft is not that sophisticated. Actually, the number of responses I can give to this when can you message, I think it's fairly limited to I can accept now or standby even. And the time in the future, to be honest, I'll have to look it up. I'm gonna look it up tomorrow morning. I got some flights scheduled tomorrow, so I'll ask them to send me a clearance or something, and try to see what my system allows me to give you as an answer. But it again comes down to the same thing with the clear to the VIA waypoint. It basically comes down to reading. And the interfacing we got right now is a screen which is 10 by 8 centimeters big at a distance of about a meter to a meter and a half. You really have to dive into it. You really have to read the message, which sounds, well, pretty familiar. Just half the solution is reading the manual, or in this case, reading the instruction correctly. And that's maybe a difference from the voice clearances we used to receive as well in previous ages, because a voice message you get over your headphone, so both pilots will receive it, and we clearly had the distinction between the pilot flying and the pilot monitoring, and the pilot flying was still able to do his flying duties while listening to his headphones or the instructions he got by voice. And CPDLC, if you want to do it correctly, it's either one pilot being head down or, well, two pilots. It's always better. At that point, you have two pilots head down, basically, and looking onto a very small screen to read the instruction correctly. And I think there is some gain to be made. There's some improvement to have in that aspect. Yeah.
Yeah, and I guess there's a situation where you lose the duplication that you have with both pilots hearing something, and that, actually, do you end up with a strategy where rather than both pilots going head down at the same time, does one do it, and then, can you confirm that you interpret this the same way as me, and you almost, but then you have to split responsibilities, and that adds, its own challenge. And
it's something we'll have to get used to. I guess CPDLC is absolutely here to stay. But again, it's something we'll have to get used to, but we'll also have to think about how we're going to implement this in a safe way. Yeah, absolutely.
And actually, it's interesting there was as you were talking about, obviously it was designed by engineers. There was a moment where I was thinking, is this where I own up that I'm actually an engineer by background? But actually, it's interesting when I'm thinking about particularly engineers and then thinking about people in safety teams, particularly looking at management of change, is what you were saying there about as you you maybe get a new fleet of aircraft or even an avionics upgrade to an existing fleet of aircraft, is actually for safety teams to be aware of, from a management of change perspective, that you might suddenly have a situation where pilots go from having maybe two choices like you do to another fleet or an avionics upgrade that increases that and increases then the risk for a problem with UM 148 that perhaps they hadn't intended, and actually us raising some raising some awareness with safety teams that there are some things in CPDLC that they would need to consider in their management of change for whatever reason, is an interesting one in itself.
Absolutely.
Cool. I never really thought of that. Well, we said we'd try and get this discussion around 20 minutes, and here we are perfectly on around 20 minutes. I guess before we wrap up, it's useful maybe just to ask each of you, maybe Pieter, I come to you first, in terms of CPDLC as a kind of future evolution in the cockpit, do you see, how do you see it? Do you think it sounds to me like it's a great addition to our existing systems? Do you see it evolving more use of it in?
Absolutely, on multiple ways. First of all, I hope to see it literally better. KLM is investing in the new Airbus 320 fleet, 321 fleet. So the 737 next generation will go out eventually. The same with the old interfacing. So yeah, interfacing should become better. The number of replies you should be able to provide is should be enhanced or should be better. And on top of that, there will be more connection between the actual clearance and the automation aboard the aboard the aircraft, right? Nowadays, I believe in the 777 or the 787, if you get some kind of clearance uploaded, it's already directly inserted into your frequency pad or your altitude display. CPDLC is definitely here to stay, especially if it becomes quicker. What I see as a pilot right now is that CPDLC is mainly used in the upper area control airspaces because some kind of time delay is allowed, especially if you get lower in Amsterdam airspace or the same thing in London. CPDLC is not quick enough. I think in the end it might be nice if CPDLC becomes the standard in terms of reliability, but also in terms of speed. Yeah, definitely. We could use it more. Less frequency congestion and less misunderstanding. Yeah.
And I guess from your side, Viktor, in your role, you're involved in kind of at the heart of the evolution of CPDLC at a system level. How are there any developments that you're able to share in that sense?
Certainly. Maybe the biggest one is that on the 20th of September, the Eurocontrol RTCA will publish the new CPDLC ATS-B2 standard, which is the ED 228229 Bravo or Revision B documents. That is an upgrade of the existing Airbus Fan C implementation. So it's going to be even better than what you're going to get on the Airbus Fan C. This is going to be the standard for the aircraft to be manufactured from 2027 onwards, pretty much. That includes both the new CPDLC V4, it's called, and the ADS-C V3, which is a downlink from the cockpit towards the controller with the contents of the flight management system. So that is probably one of the biggest things in the future. And as Pieter mentioned, in the newer avionics, like in the new Airbuses, you already have the Fan C system, which allows the pilots to push load horizontal clearances. That also allows the controllers, for example, to uplink latitude, longitude coordinates instead of using headings. And the pilot can just, with a simple move, push the load button, put it into the FMS, and then not having to interpret anymore what is the first point and what is the last point. So those things are really great. Also, there's less bing bongs because the messages, what you mentioned, are becoming system management messages. So they update the necessary systems on board, but they don't alert the pilot anymore because we realize in the meanwhile that there is no need to alert the pilot about who is the next sector and who is this and who is that. So indeed, that is those are a few areas where we will see the improvements. And also ICAO will release the next global operational data link manual, the gold manual, or ICAO Doc 10037 next year. And that will already include a recommendation for aircraft manufacturers for the recommended display of CPDLC messages. So as to avoid this understanding, currently there is the work still ongoing on that with the involvement of IATA and IFALPA and the ICAO PDLWG, the Operational Data Link Working Group. We expect to approve the goal document by December and then publish it by the next year. And we were promised by the avionics manufacturers that the goal document they will definitely take into account, even though it's going to be a recommendation, not a requirement. But they try to pay attention to what is recommended in the code for the future messages, and that will apply for all kinds of aircraft. So not only for the newest system, ATS-B2 system, but also for the other standard.
It's one of the things I love. Whatever safety topic we talk about, I particularly love that the evolution of technology just changes so many things that a lot of people, unless you live with it every day, you don't necessarily think about it. So yeah, it's great to share these ideas and find out more, and hopefully help. Particularly, I said a lot of what we're trying to do is help safety teams, particularly in organizations, have a better understanding of what the frontline kind of workers, the pilots, the controllers are going through, and how they can help kind of connect the dots at an organization level. So yeah, hopefully everybody found that a really good discussion. I know I learned quite a lot, and it really links nicely all the different things that we were promoting in our work. And yeah, thanks to both of you for a really interesting discussion. So thanks for joining us, and thanks to everybody for listening. Yeah, see you next time.
You're welcome.
Thanks. Bye.
Cheers. Bye-bye.
Bye.